Okay. Thank you all for coming to the breakout session. I am Chaco Daniel. I am a principal program manager with the hyperscale compute team in Azure. So in this session, we will be going over the various capabilities of Service Fabric in terms of managing your services, upgrading your services, upgrading your configurations, and so forth. So in this new world, as a developer, you have multiple hats you wear. One of those things which is a norm at this point is your service has to be up 24/7, 365 days a year. And in that duration, you also not only have to add new features, but also have to make sure that you have the ability to deploy new features, monitor, troubleshoot, diagnose, fix issues in real time. You cannot afford a downtime at all. So the architecture you put in place the first time you deploy into production has to be working and should meet the needs even after 5 years. And that actually is the key thing which we will help you do. So let me first give you a quick overview of the platform. So I'll keep it brief since I'm sure most of you guys have attended Gopal's sessions on the architecture talk on this Service Fabric, and also the session which was on the other room about the programming model. So I'll just quickly go into what this particular big picture is out here. The Microsoft Service Fabric has been a key ingredient in taking all of our tier 1 box products like SQL, Link, and other like DocDB, and transforming them into running as cloud services. The Microsoft Service Fabric is a proven distributed platform that makes it easy to build scalable and reliable services, allows you to keep compute and associated state together to achieve high throughput and low latency, allows you to manage the full application lifecycle, deploy, scale, monitor, troubleshoot, and upgrade applications easily without any downtime. The code you develop and test on your development environment is the one which you deploy onto the cloud, or maybe including the private clouds you may have. For example, in terms of scale, I just want to talk about SQL Azure. SQL Azure is one of the largest and the complex users of this application lifecycle management features of the Service Fabric. They regularly kick off close to 40,000 application upgrades in each of their clusters worldwide, and the platform handles this without any issues. So you're getting a platform that is tested for its seams on a daily basis. So anyway, that's the brief introduction into the platform. Let's get into the management and application lifecycle capabilities. So one of those things which may have been in back of your mind is, what are the challenges for managing distributed applications at scale? Actually, I remember reading a study which said, on an average, a single downtime for an hour costs around $300,000. So of course, no customer wants to take that kind of a hit. So you absolutely need some reliable optics into your health of your application, so that you know if some partitions are running hot, or do you need to scale my application up, or scale the environment out. So having said that, say for example, how many times it's happened that you've woken up at night just to add some capacity to your environment? So you would of course like to have a platform which just does it for you. So that is actually Service Fabric. And while the platform is doing some of the scale outs, why doesn't it also do some of the self-healing and repairs based on some policy you set? Say, for example, you could say, if my application service comes down for some reason, just restart it, and then don't wake me up. But if it's restarted, if it doesn't come back, then there is a health threshold. If it meets it, okay, then life is good. Don't call me. But if it really becomes a crisis, then of course call me. I'm always available that way. And the other thing which is interesting is, I don't know how many people have taken production support calls when you're on vacation. And just to just to find out that, oh, that was a false alarm. So now you've disturbed your family, you've done all those things, and just to get a false alarm on something. So you don't want such things to happen. So the key would be that you want to have a system which actually will accurately describe to you what's going on in the clusters. It is not an opaque thing. It has to be something which will give you deep insights into your application, its health, its performance, what stress is running. So these are the things which the management stack of Service Fabric provides for you. So the other thing that was interesting in here is I have this bullet point talking about the testing of it. So think about a scenario where you have now been called into a live site incident. You figured out what the fix is, and then you just want to have some more guarantees as to, yes, this is the right fix. And you need a platform which actually allows you to test some scenarios which can happen very regularly in production. So System Fabric provides you a testability framework for it, and which you can plug into. And then the other thing is the configuration management. That is another one of the big topics which people keep talking about. And for example, how easy was it to deploy a fix confidently into production without being on pins and needles, worried if I messed up some configuration, and did I deploy the right version into the right cluster? And those are the things which actually are very easy to do in Service Fabric. So let me now go into some of the details of each of these bullet points I listed, and then I can give you some more interesting feature descriptions. So before I get into it, I'm sure you guys have seen this diagram multiple times by now. So this basically just is actually a collection of machines, and they are only as reliable and fault tolerant as the individual units. So now let me introduce you to the System Fabric cluster. So System Fabric cluster is basically is a set of machines which could be physical on your on-prem scenarios or virtual in Azure or any other cloud provider you may have, and then it stitches together to form a reliable and a fault-tolerant unit called a cluster. These clusters, of course, can be as small as five nodes to thousands of nodes of machine, thousands of nodes. SQL Azure, for example, in almost every region, they have clusters which use up close to thousands of machines. And then the other thing which is unique about our Service Fabric is that when you're setting up your cluster, you can specify the failures the cluster should survive. For example, you can choose to set up a cluster that spans more than one Azure data center. The reason why you would do that is, hey, in case I'm so paranoid that if one of the Azure data centers has an impact, my service should not be affected. And so, for example, like one of our internal services called Bing and Cortana, they have clusters which span 3 data centers. And so, only last year, one of the sets of machines in one of the regions went down, and then they didn't even feel that it went down because there was no impact to the service. Service Fabric just failed them over to the other 2, and then after a while, and when they got all these alerts saying that so many machines are down, that's when they realized, oh, apparently a set of machines in one region went down. So in fact, we got a lot of kudos saying, oh yeah, it really works. So this is the same software we're releasing to you in terms of SDK, which was like yesterday. So I'll actually go through a little bit more detail about how to plan for your production clusters later on in the session. So quickly, let me also touch on what applications a Service Fabric application is made of. So of course, Azure Service Fabric supports the creation of both stateless and stateful microservices. And so each of these services, of course, contains a code and an associated configuration to form a service package. Then the service package is the one which you define to Service Fabric, saying that is my service type, and that actually is the unit of deployment and activation. So the way to think about these service packages they are actually you could think in terms of it provides you a complete functionality, a standalone. It can actually be deployed independently. It can run independently. That's how you should think in terms of a service package. And then each of these service packages, of course, has to be contained in something. And that container is called, for us, it's one of the containers is called the application package. This application package is actually the unit of lifetime versioning and isolation. Like let me give you a simple example. Like for example, an online ticketing application may contain an inventory management service, a payment service, and a printing service. All these three actually can be independently upgraded, can be deployed, and so these can actually be separate service packages of their own. Say in this particular schematic I have got there, if you look at it, one of the packages is 100 MB and the other one is 2 gigs. The reason I took these extreme examples is because a lot of times you don't want to touch this 2 gig application package because, the service package, because I have problems failing them over. I have problems making sure that everything in that is correct. All I have to fix is a small little package upstairs, package A, and that I should be able to do that. So that is the unit of deployment and activation, whereas the application package itself is actually the isolation guarantees which you get on the versioning. So hopefully those are the two things I want to make sure that you guys remember. And we'll use these terms over and over. All right, let me quickly go through an instantiation of this application, like these microservices or the services as the code packages we just talked about. Like for example, you have an application 4 which is ready to go, and it has 2 services, service types A and B. Services. The service fabric will figure out as to given where to place all these instances of this service type A and service type B. And if you look at the way it's placed it now in this particular thing is, if you look at it, it has actually made sure that each of these instances of the services do get a unique fault domain and the UDs. This actually is the key to making sure that you are actually on a reliable placement. So there is also the concepts of scaling up and partitioning, which I will talk about later. So let me just show you how these are done. Well, one other thing which, okay, this one, basically is I wanted to specifically call out every service instance has a unique name in the namespace of the application. That is actually how you address those service types which you just instantiated. Okay. So demo. Let me switch to demo number 8. Okay. So in this demo, actually, I will show you a couple of things. First, before I go in there, I just wanted to make sure, I'm going to show you a preview into our portal. This is a service which I think Gopal mentioned, also Mark mentioned, that there will be a preview service which will actually be in Azure, and you can actually request for these things. So I'm going to give you a preview to that. Okay. So like all Ibiza portals, you just go new, and then since I've already created one, it's showing up there. So you can actually, in this scenario, it will show up a little more prominently. But today, since it's actually a preview, I'll just give you a quick overview of how it's going to be. So I'm going to set up a cluster. So this is how it will work. So you're going to create. What's going on? Go this way. All right, so you select your own cluster name. It's up to you what you want to do. So I would just say service fabric demo on stage 1, just because hopefully this will go through fine. All right, so then actually if you look at what's right below it, basically since it's defaulted this location to West US, actually you get a West US address. If you change to East US, then that's what you'll get. So anyway, this is nothing new in terms of Service Fabric itself. Is actually a property of the portal and Ibiza itself. So I'm going to create a new resource group. Since I am one of those people who doesn't remember all these names, I'm going to keep the same thing. So Mark Russ actually talked about resource groups. I don't know how many people remember. So this basically any resource you create has to be in a resource group. It actually allows you two things. At least for me, it's a good way to see what did it take to create this cluster. So I will show you what a resource group will end up containing once we just deploy this. So in terms of basically, I created this service group now, and then the subscription. This of course has all the subscriptions which you have access to. Location, of course, today, at least for this trial run, we actually have it only on 4 regions, and I'm just going to choose West US at this point. Then here is where actually you have to make some decisions. Some decisions basically is what kind of VMs do you want this particular cluster to have. So in this scenario, I'm just going to say, okay, I'll need 5 of these VMs. You can actually choose any number. I just have defaulted it to 5, 10, 15, and 50. You can actually choose 1, 2, 3, 4, 5, and so forth. So anything above 5 is the right number to choose. So the name of the VM, you can just say this is the stage. So this particular prefix actually all it's used for is name each of the VMs. So we actually generate names for you. So the one thing which you have to enter since this is actually built, this service fabric is will be built inside the IaaS VMs. You actually have to give some, you have to choose a username and a password. This actually is for RDPing into the cluster, into each of the VMs. So I'm just going okay. So at this point, basically, there's a couple of more options. Okay, so you of course, if it's something if this is a cluster which you're using for your development purposes, most likely you don't want it to be secure and it's easier. But if it is a production cluster, absolutely you want to secure it. And I always suggest that even if it's a development cluster, it's always good to secure it because you don't want it to be DOSed by someone else. So it's best to just do it. So we allow you both these options. One. So basically you can choose to say, I don't need any security. The other one is you can actually give it a certificate, and then it'll select the rest of the options in here, talking about okay, where can I find this certificate? So this certificate you should have provisioned into a key management store already, and so you're just giving the URL of the key management store, and that's how it comes here. So anyway, so for this purposes, I'll just make it non-secure, and then let's go on. Okay, create. So it's created. So since it's going to take like 5-10 minutes, so I'm just going to go and just take a cluster which I already have. So service fabric clusters. Okay, let me take this one. This actually is the cluster which I'm going to use for our demos today. So if you look at it, in this blade, basically a couple of things which are interesting in here in terms of essentials tab, which you have. Let me just look at the time for a second. Okay. So this basically this one out here is actually your IP address which you would use, the FQDN which you would use to connect to this cluster. And then here there are some of the few other things here. Node monitor. This actually just gives you real time as to what's going on with your cluster. So, and we have actually 3 states which are more interesting. So for a node, you either the node is in error, or it could be everything is good, it's reacting well. Then there's unknown. Unknown comes in only if it's just barely joined and we don't know its state. And then warning is when there's something is really going on. So basically, that's the health state directly from the system. Then application, actually here I have deployed 2 applications in it. So it just says that there are 2 of them okay, and then there are none in warning. So I'll just quickly go into these. The reason why actually we split this into the different states is most often than not, if it's okay, you actually have no real reason to go in and see if your node is okay, and because you should just trust the system. But in this scenario, I'll just go in and say, okay, here's a cluster of 9 nodes, and I have and all of them are okay. And then if you look at it, basically we have striped it across FDs and UDs combination. So there are 3 FDs, and then there are 5 upgrade domains. And we can actually go through, if you have the time, we actually certainly can talk about the upgrade domain concepts a little bit later. So basically, this is used when you're upgrading your applications. That's when the upgrade domains are used. All right, so then let's just go quickly into a few more things which we just talked about. So application monitor, there are 2 applications I have in here. So let's just look at the one of these. So in this, it just says that the health state is okay, and here's a version of these applications. This is the address of the application, and this is the namespace under which the rest of the services will be under. And in this particular application, there are services, and then there are 2 services in them. One of them is a, let me just increase it a little bit. One of them is a stateful one, another is a stateless one. And then, so the key here is we now went in from the cluster, you went to applications, and then applications down to services. And here is, now we can actually, let's go into a stateful application here. If you look at it, so then actually it actually gets into how many partitions it has. And then if you go to the partition, that's when you see that it's running as a single partition, and it's healthy. So our health state now, if you step back and think about it, we report health at different levels. One, at the cluster level, at the application level, at the service level, at the partition level, at the replica level. So we actually do all the way down, and then each of these are well defined in terms of health states. It can have okay, errors, warning, and then there's an unknown, just because there may be scenarios where system itself is waiting for some health report to come up, and that's a very rare state to happen. So it's still there. And what's interesting about all these things, the health framework is, we'll talk about more about health framework a little later, but is that you can also report health. If you actually have a watchdog, if you have an external service which actually is going to report health on the behalf of your application, you can still use this framework to report it, and then this will all show up in the portal. So anyway, so now that we have seen this, let me now do one thing. So I want to also introduce you to this particular tool, which actually you can use till you have access to the portal. The portal, of course, comes in only at public preview. Till then, this is the tool which we have shipped as a part of the SDK. So in this particular cluster is here. So not this one. This was the one I was playing with. So this one basically has the chaos test app and the cluster monitor. Those are the things we just saw. It talks about the versioning as well. So just for this demo, what I'll do is let me just bring up one of the applications I have here. This actually is the application which has this bouncing pyramids, which I'm sure you guys have seen in the other demos. So now I'm going to get into the details of what each of these, how do you define it in terms of management, in terms of versioning, how do you define an application to Service Fabric. So application type itself is defined by the application manifest. So in this manifest, in this thing, actually I have two services. One of them is a stateful visual objects service package, and the other one is a visual objects web package. Each of them have a version of version of 1, and then basically it says the services are at version 1, and then it says that the application is also version 1. Okay, and then where do you define these two? So this would be defined in a service manifest. So for each of these service types, you actually have a manifest which actually describes it for you. And so each of these have a code which is a version 1, and then there's a code config of version 1. And then we also then in turn also version in the service manifest, which actually is referred to in the application manifest. Look at it here. Service Fabric itself does not care about what scheme you use. You can actually call it version A, version B, version C, it doesn't matter. So whatever makes sense to you. A lot of customers just even call it, okay, this is the version number like 2017 dot something, because that's how it makes sense to them. So there's no versioning scheme, it's just basically a string. And all we care about is when you go to deploy it and then upgrade it later, we just want to make sure that this actually is different from what's already running. And as long as you are making sure that you have a way or methodology of versioning it, you should just go with it. In this scenario, I've just taken this 4-part versioning scheme. That's all it is. All right, so Visual Studio, I'm just going to rebuild the solution. It's going to be here quickly. And then I'm going to package it. While that is packaged. So I have two options here now. One, certainly I can connect to my cluster from here, from the Visual Studio, and then deploy it. So that portion of it was a talk which like it was the last hour you guys heard Vipul and Mark talk about. So I'm going to use PowerShell because that seems to be the operational tool. Most of the time you'll be using that once you have stuff in production. So let me just use that. So a couple of things which is very interesting. So very first thing which you define in this scenario is like you have to copy this package which you just created into the image store which is running in our cluster. So I already copied it once, and certainly when I show you upgrade, I will certainly copy it. So just for the sake of time, I just copied it now. So then the next thing you do is tell the cluster that yes, I have actually a new application type. And then all you're doing is instantiate one copy of this. And that's new. So if you now look at this, you should be, when you look at it, it is actually there. So if you see Visual Objects Application, so it just says, yes, I understand these things, and now you would see that is actually deployed. And I have actually, and these are actually have 9 partitions actually, since I said that it actually has to be on all the machines, and that's how it happened. So let's just look at the output of this for a second, because that's going to be the fun thing about it. So there it is. I don't know whether you guys can see it well, but I don't know what's going on here. All right, so let me just put it on another one here. Okay, much better. Okay, so we now have bouncing pyramids. So let's just do a quick upgrade and then actually, or maybe it's okay. Let's just come to the upgrade a little later. So let's go back to the rest of the stuff which I wanted to talk about. All right. So then the other concept which I want to also talk about is the ability for you to make sure that you can upgrade a single code package. In this scenario, what I will do is basically upgrade one of the service packages which I have. So in this particular schematic I have here, I'm just going to update the yellow hexagons with the green ones, and then basically the system takes care of placing it one UD at a time. It actually is going to walk through. Basically, what happens is the upgrades progresses from one UD at a time, and a UD sequence actually is chosen by System Fabric. So you don't get to choose which UDs go first, but it's done by System Fabric. But it will always do one UD at a time so that you don't lose any availability. The health checks are also performed at the beginning of each upgrade and at the end of each UD, so that if the health policies are not met, the upgrade is either rolled back automatically or is paused so that the application developer can then debug the issue. And then we go a step further. The application developer can then either restart the upgrade, saying that, okay, I think it was a false alarm, let me just go on, or tell the system to roll back or roll forward. So both those three are the options. You can restart the upgrade, you can proceed forward, or just roll back. At no point is the service availability lost. And so the question I'm sure you guys are thinking about is what kind of health policies can I define? So there are two levels you can define this health policies at. One is at the cluster level. You can just say that out of these 9 machines I've got, as long as this upgrade doesn't impact more than 2, or I'm okay. So you can just say, okay, 10% of my nodes or 20% of nodes can be down. It's all right. There's no need to roll back. But you can also specify that at the application, you don't want to lose availability of it at all. So you can just mention that none of my applications should lose availability. If it does, then you just have a policy you can choose to say, do you now pause, do you roll forward, or roll back? So these are the things which you can do. So let me show you this in action. All right, so number 8. So I'm back here. So what I'm going to do very simply is I'll go to my stateful objects actor.cs, which is actually in one of my, it's actually in one of my service packages here. It's actually in this. And then I'm just going to make a small change here. I don't know whether you guys can see there. Maybe I can just increase it a little bit. So I'll just make the movement to be true. So that's just basically all it does is make the pyramids rotate. That's all it does. So I'm going to use Visual Studio to compile it, and then package. Where is package? Package. Okay, once it's packaged, certainly I can deploy from here, but I just wanted to go through I want to show you specifically what are the few things which you actually have to think about. In this particular scenario, the only thing which we changed was one of the packages. So let's just go to the package at this point, the release. So since you see the Visual Studio actually generated 2 of them. So we certainly did not change this guy. So I'm just going to remove that package. Just going to remove that. So this is the one which I changed. So I just go in, I edit my service manifest. It'll come up. It comes up. And then all I'm going to do is make these changes. So this is version number 2. And then I say, okay, I change the code a little bit. And then I'm also going to change the associated config for it. And then just save it back. Okay. And then you go back and then define the same thing in your application manifest. So that now you can indicate to the system that, yes, I actually changed this Visual Objects Service package to version number 2. I did not change the Visual Objects one, which is the web package. I did not want to touch it. It's working just fine. And then I just changed the application version here. That's it. And then you're going to save it. And then the next thing which you do, go to PowerShell. You're going to say F8, then copy it. Now you're copying that package into image store. So it says that it's copied. I'm going to register this new one. So once you register, let me just go back quickly to this thing and see the last time when we saw, there were actually this one version of the application sitting in there. This is the view to your image store. So let me quickly refresh it. And then let me go back to the application here. And you see there is actually now a second version of your application registered. In this very clearly, only one of the packages has changed, the second one has not changed. So the system itself now understands that it doesn't need to go touch the Visual Objects web service at all. The only thing it's going to touch is the stateful one. So now let's just quickly go and initiate the upgrade. So this is the PowerShell command, starts the service fabric application. Just run it, and then we can actually go back. Let me also bring my this thing here. So it says it's upgrading. So shortly you should see this, like this blue one basically started to rotate. And then let me just do the refresh here. So as it progresses, you can actually see it. So let me just pull this out here. So basically, what you're seeing is that each one of them slowly starts to, as the UDs progress, as the upgrade progresses through the upgrade domains, each of these little bouncing pyramids starts to have rotation included in them. So that's what you would see. And then now it just says that it has completed 2 UDs. So you should have at least 2 of them which have now started to have rotations in addition to bouncing around. So I let this go. Okay, let me just go on to and we'll come back to this. Okay. So here is an interesting one. So now that you have an application, I showed you that it can be upgraded, and so I want to talk to you about what are all the key aspects which are features which are built into Azure Service Fabric that will help you deploy your application into production with confidence. One, security. Security is a very big thing for customers, and in fact for Microsoft it's even bigger deal. So security was built ground up into the platform. We support role-based access control. You can use certificates to secure your application and the cluster. All the system logs and events are logged. Application logs and traces are retained per the customer policies you have set. So this is something which you can say, okay, I need to have 7 weeks of logs, and that's what you can actually choose to indicate to the system, and that's what you would keep. Application scale up. So when you're a small startup or testing the market out, there's a strong need to be able to offer the service with minimal expense, but with the ability to scale out if needed. So there is no telling as to when you would have a spike in the need, and then that's when you don't want to go and deploy a new set of applications at that point. Azure Service Fabric allows you to just do that by allowing you to partition your application. You can choose a very large partition size. Say, for example, it's plus minus in 64 partitions, and deploy it to a small cluster. And so you're paying only for the expenses of that particular cluster. Right? So that actually would mean that your COGS are lower to start with. And then as the demand increases, you can actually say, okay, Service Fabric, increase it to whatever it needs to be, maybe go from 9 to, say, 900. So that's exactly what can happen. So then the next topic would be application reliability. And so what kind of failures do you want to survive? What's your SLA? How many replicas does your service need? These are the questions you need to ask about when you think in terms of reliability, which you need. You can also think in terms of, okay, do I want to survive like in an Azure data center going down? So those are the times when you span Azure data centers. So these are the questions that you have to ask yourself. And the System Fabric, of course, allows you to not only think about these things, but also make sure that it's implemented the right way. And then, there's 2 more things. Okay, a testability service. This actually is a service which actually allows you to test your applications with real-life scenarios, which can happen in production. No one wants to test the limits of their service in production. So putting customer data or your SLAs with them at risk. So this inbuilt service can be used to simulate real-world scenarios which may happen in years' time in terms of hours. So all you need to do is simply enable this particular service in your test cluster, and then basically it will the application, your application through spaces. Since this service is also integrated with your health system, it will pause this test if the application fails. So this is very important, so that then as soon as the application has a fault, it pauses, and so you can attach and debug and fix the issue. And then you get to restart the applications, the testability service at that point. So then let me go on to the last topic, which is actually the health monitoring and diagnostics, and that one actually I will cover after the demo. Actually, let me just give you a demo of this, the testability service. Okay, so I want to introduce you to this cluster monitor which we have, which I'm sure you guys have seen this before. So now I have a nice UI out here, which indicates the 9 nodes which I have here, 9 nodes, and then I have a lot of applications deployed into it. And so I just wanted to talk to you about a couple of things. So we have not talked about, let me show you a couple of interesting things here. So in terms of reliability, what does it give you? So let me take this particular service fabric explorer, and then just kill off a node. So for example, let me just take this 20157. So you would see something very interesting in here. So activate, and it's asking me, should I restart? So when I do it, so you would see that the system fabric actually moved all those replicas off this into something else. So basically, this is actually simulating a scenario where you actually lost a particular node in production. And then when it comes back, the services, the replicas will move back. So see, that moves back. Okay, so this is something which, of course, you can sit on your terminal and try to do this once in a while, and it actually is not very scalable. So let's just see if we can. All right, let me just bring up my testability service. Just give me a second. All right, I don't know where it is. Yeah. Yes, there it is. So anyway, so for the lack of time, actually, I'm going to move on, and I will show you guys the testability service some other time, I guess. So let me just switch back. So what we found at this point is basically Service Fabric is a state-of-the-art containers orchestration service. It allows you to specify rules around placement, resource balancing, resource consumptions, node capacity, and update them in real time. You can adjust these on a running cluster, and the system will manage the resource balancing for you. For example, SQL uses this a lot. Basically, they offer 3 kinds of databases, say for example, and they have standard, free, and a premium. So they define the node capacity such that the premium database reports its load as that just takes up the whole complete machine. So then what happens is, since the premium database is already taken up the whole machine, then the system fabric actually knows that not to place any of the free SKUs out there. And so these rules are respected even while you're performing an application upgrade or rollback. So let me quickly show you how easy it is for you to define the node capacity and report some loads. So I have an application out here. So this particular there is a manifest called cluster manifest. The cluster manifest actually it's nothing but which defines the cluster which we just deployed. And then in this basically in each of these node types or each of the VMs, we can actually say here, the capacity of the VM is just this. So if you just add this particular segment to it, then the system knows here's the capacity for that. And then from your service, all you're doing is you just make a call here, and just report the load. And based on the load, the system will react to it and figure out, okay, this particular one is taking up 20 out of the 80, and then it will react to it and make sure that wherever it's placed, it just takes into consideration how much of the capacity of this one. This one just talks about 100, so it can place only 5 of them in there. So if it hits more than, if there is a 6th one, then basically it actually will report that either there's no space or it will just place it in a node which has the space. So it's very easy for you to report load from an application. All right, now let's just go into the topic, the very last topic which I had talked about is monitoring your services. While running your service in production, it's critical that you have visibility into your application and what your application and services are doing. And I categorize them into 3. One is performance and stress response, service health status, collection of telemetry data on your service. And Microsoft Service Fabric enables you to do all of these with ease. For performance monitoring, we emit detailed platform metrics for both the programming models. The programming models which Mark and Vipul talked about, for both of them, we actually emit detailed platform metrics. You can combine them with your own custom metrics to understand as to how your application is handling spikes and surges of customer load. Figure out what's the slowest API calls, and also tweak your code. And those things you can use to tweak your code. So, or maybe even understand what are the characteristics of say a data save or a data load. Since we emit standard ETW events, you can use any tool which you want, which of your choice, and then you can visualize this. Then the second topic was health status monitoring. For health monitoring, we have built a flexible and extensible health store that provides reports of health of the cluster, the applications, the system services running in it, and you can easily add reports for your application and services you write. You can check the health status reports on the portal, which I just showed you in the Service Fabric. That's the other thing, and the Service Fabric Explorer. That's the other tool which is also shipped for you in the SDK. And then you can certainly plumb this into any other tool of your choice which you may need. The platform uses this health store for many of its actions, including monitored application upgrades, and it actually uses that to safely roll back if there's a new version of the application which is destabilizing your production environment. The last one, which is also a part of your monitoring your service, actually is the business telemetry. In this day and age of data-driven decision making, we enable you to collect, analyze, drive insights from your customer interaction in your application. Let me quickly show you an example of how you can use App Insights to surface the system-generated counters along with any system, any of the custom counters you may have created in your application. Number 8. Okay, App Insight. Let me go to the portal. You go to the browse. Let's look at App Insights. I have actually one of the app insights already created out here. Come on. Let me go to my favorite queries which I run. Okay, there you are. So there is the demo charts. So if you will see something which is interesting out here. So what it just gave you is basically a list of system generated counters. So this basically says that the number of actors I have saved in this particular cluster over the past 24 hours is 42.53K. The number of, okay, I can hover over it. This is the number of async calls. The get, this is the set for actor. You can just keep going down. So the key here is you can actually have your own custom metrics, or you can actually look at the ones which system generates for you, and then of course use all the powers of app insights to make sense of what is going on with your application. Let me just quickly go back. All right, so let's look at the one more interesting thing. So we talked about monitoring, we talked about health. Now it's interesting to see what are the tools which Service Fabric provides you for diagnosis and troubleshooting. I've broken them into 3 buckets because that is the easier way for me to understand this. So detailed system optics. This actually allows you to know what Service Fabric was doing at the time of the incident. It is typically, it's very helpful for you to know what the system was doing so that you can actually rule the system as an issue and be more focused on what exactly happened at that point based on the system event and the application thing. So for example, the system optics include all tracing of important system events, such as application service deployment, the upgrades, the actor creation, save and load state calls, or like slow async cancellations, run async calls that are failing, and so forth. The second piece of it is the second bucket which I have is the custom application training. This is the only way for you to make sure that you can extend the functionality which Service Fabric provides you out of the box. So you can combine your own application traces with the system traces to get a holistic understanding for you to troubleshoot a problem. And we use ETW. So your custom tracing code you added on your local one box actually works exactly the same way when you deploy into the cloud. So you don't have to rewrite it. You can certainly use any tool of your choice to visualize these traces. I'm sure people like Kibana, you like Elasticsearch, you can use operational insights, event log, or the VS Diagnostics Event Viewer, which actually is a part of the SDK which you get. So in the programming model talk, I'm sure Mark and Vipul actually use the Visual Studio Diagnostics Event Viewer by pressing F5. So I will not show you that, but I'll just show you how these can be done in the Azure Operational Insights. Number 8. Okay, so let me just get to, so I don't know how many folks have actually played with Operational Insights. So I will not actually get into the details of what Operational Insights itself is, because that's another talk by itself. So let's just go through very quickly. I wanted to understand, I've now made sure that I've actually routed all my traces and all the events which I have over the course of some time into an XStore, and then basically Operational Insights actually is the one which I'm using to query it. So let me find out, basically give me all the system events that notifying that an application upgrade has started. So like you say, okay, here it is, and then It just says, oh, yep, on Sunday 26th, there was something which happened. And then if you just look at it, it actually will tell you that, yes, there was something which happened there, and it was an upgrade. And give me all the events which, for which when an application was created. And here's the complete list for it. And so this one, what I'm trying to indicate here is the searches you create are something which you can leverage using the keywords which we will publish. We'll just say, okay, you can actually search for application created, application upgrade started, application got deleted, the application upgrade completed, and so forth. So that's about the thing I wanted to show you in terms of the ops insights. So this actually can be used for figuring out what actually exactly happened in your cluster. So, okay, let me just go back to my PowerPoint very quickly. Let me see how much of time I have. I have 3 minutes. Okay. So diagnostics and troubleshooting. This actually is a high-level workflow of how does this truly work. In a distributed platform which has like hundreds of machines, there certainly you can't actually expect all the events to flow one at a time. So you actually we allow you to use Windows Azure Diagnostics, and that actually in turn pumps it into an Azure table and then the ops insight. So that's exactly what you just saw. Example of system optics, of course, includes the actor creation, save, load calls, and so forth. All right, so now we come to the end of my talk. So I'm just going to recap as to what we just talked about. Service Fabric management capabilities that will enable you to run the your services without downtime 24/7, 365 days a year. Service Fabric can manage clusters small and large, handle failures, machines, or applications automatically, and is unaffected by hardware, software, or communication failures. Makes application lifecycle easy, supports automated, monitored rolling upgrades with rollback, since it actually is tied into our health store. It gives you a container orchestration, automatic resource balancing, governance based on rules, ensures efficiency, performance, scale, density, resulting in better COGS, and provides extensible health, diagnostics, and monitoring. I just showed you those. So I've come to the end of my talk. Thank you for listening. And I have something for you. Just try this SDK today. We need your feedback. Thank you very much.